opportunity. Ramila, please, and Zaki, thank you. Prompt us if you are about to take the picture. Sando, Ferdinand, bahay na bahay.
1, 2, 3. Okay na.
Another one.
One, two, three. Okay na.
Okay, thank you. Let me share my screen. Jiro, hindi, sabi mo pupuntahan mo to sa nung Wednesday. Diyos ko, ganito pa rin. 28 years bago magbukas. So same, we will have 2 activities for tonight. All about frequency distribution table. May I request that it will cost you a lot? Will it cost you a lot if you are going to print the activity then by pair? Because it's very difficult to check online. Will it cost you a lot? So that you will submit after the face-to-face or just online? Walang nasagot. Online. So individual again. Because it's difficult to check via online. Well, anyway, it's for me to adjust. So activity number 6 is all about the frequency distribution table and histogram. So histogram is the special type of graph only for the frequency distribution table. A special type, so FDT and histogram, these are special types of tabular and graphical presentations. Remember that we have 3 ways to present data: narrative, tabular, and graphical. And FDT, or the frequency distribution table, and histogram are the special types of tabular and graphical presentations. So these are used to depict the distribution of the data, and most of the time, these are used in technical reports. As I have mentioned during our face-to-face classes, the tabular method are commonly used in technical reports, and this is a special type of technical report. The frequency distribution table, or simply FDT, is a presentation containing non-overlapping categories or classes of a variable and the frequencies or counts of the observations falling into the categories or classes. So for tonight, I will teach you on how to construct a frequency distribution table. There are several types of frequency distribution table, and we're going to tackle it one by one. There are two types of frequency distribution table according to the type of data being organized. So depending on the size of the universe, how many are included in your observations? How many are included in your survey, or how many are included in your interview? So the first type is the qualitative frequency distribution table. If there is a qualitative frequency distribution table, there is also a quantitative frequency distribution table. We will start with the difficult one, the quantitative FDT, and we will just have the qualitative FDT during our face-to-face class next week. Qualitative FDT is the non-overlapping categories of the variable are identified, and frequencies as well as the percentages of observations falling into the categories are computed. So basically, it's called frequency distribution table because you are counting the frequency distributed to every class size or every category. You will know the terms later. Under quantitative frequency distribution table, there are also two types. So on the other hand, for a quantitative FDT, there are also of two types, the ungrouped and the grouped. So for tonight, we will have the frequency distribution table of the grouped and ungrouped. So ungrouped FDT is constructed when there are only a few observations or if the data set contains only few possible values. As I have said earlier, that you will only use the ungrouped FDT if the number of observations is less than 30. If the number of observations or the size, the number of units is greater than 30 or greater than or equal to 30, then you will use the group FDT. So it is constructed when there is a large number of observations and when the data set involves many possible values. For ungrouped, n is less than 30. For group, n is greater than or equal to 30. So this is a sample frequency distribution table wherein you are going to find the R, the K, and the C. Then you will have the table title, and all of the rest will be computed. So this is the start of the computation part of the statistics because we have finished already exploring the types of data. Now that you are equipped in knowing the types of data, the qualitative or quantitative, the scales of measurement, and the basic terms in statistics, we will now start the computation of the statistical tools that we are going to tackle. So as a sample, table 1, weight in kilograms of the 60 students of mathematical statistics for IT who participated in answering the student information sheet or the SI. Since your N is greater than or equal to 30, it is stated there, it is reflected that the N is equal to 60, it will fall under the grouped frequency distribution table. So the first that we are going to compute is the R or the range. It is very easy to find the range. Identify the largest data value or the maximum, max, and smallest data value or the minimum from the given data set and compute the range R. The range is the difference between the largest and smallest value. That is R is equal to max minus min. So meaning you just have to find the maximum number in the data set, then you will subtract it to the minimum number in the data set. So for this example, what is the maximum value and the minimum value? So so that we could compute the range. Anyone?
100 po, sir, yung max.
10 minutes ago. 100. So the maximum value is 100, while the minimum is, raise your hand so that I could recognize your recitation. So the minimum, may sumagod na ulit,
27.
is 27. So after finding the maximum value and the minimum value, we could now compute for the range. So again, the formula for the range is equal to max minus min. Max is 100 and minimum is 27. So you are all correct. So by applying the formula, substituting the values, R is equal to 100 minus 27. Therefore, your R is equal to 73. So you will write it down in the R provided in the sample group quantitative FDT. So this is only a sample grouped quantitative FDT. Later on, the ungrouped quantitative FDT. So your R is 73. Now, we will now compute for the K because it is required to compute for the R, K, and C before we could have the values here in the body. So your K, or the number of classes. So to determine the number of classes K, we will use the formula K is equal to the square root of N, where N is the total number of observations in the data set. So round off K to the nearest whole number, and it should be noted that the computed K might not be equal to the actual number of classes constructed in an FDT. But most particularly, it is equal to the actual number of classes constructed in an FDT. If it is not equal, there is a margin of error of plus minus 1. So meaning if the number of classes, let's say, is 8, that is the exact number of classes. If your computation will give you 7 or will give you 9, it's also okay. For as long as it is within the margin of error. So to compute, K is equal to the square root of N. How many observations again do we have? It is stated in the table. How many observations? What is your N? Justin?
50 po kasi.
Is it 50? Okay, Dirk. It's 60. Your N is equal to 60. There are 60 respondents that were classified under the SIS. So using the formula, K is equal to the square root of N. So all you have to do is to substitute the value of N to the formula. Then we will have K is equal to the square root of 60. Using your calculator, the value of K will be K is equal to calculator. So Zaki,
Sir.
7.7. So K is equal to actually 7.75 or approximately equal to or rounded off. Itong kulot na equal is approximately equal to 8 or rounded off to 8 because the K must be rounded off to the nearest whole number. So therefore, K is equal to is approximately equal to 8. Then you will write the K here, 8. So your range is 73 Your number of classes will be 8. Now we will compute for the C. And it is given by the definition class size. So C stands for class size. So in calculating the class size C, we will use the formula C is equal to the range divided by the number of classes. So if your range and number of classes are wrong, the entire FDT will be wrong. So make sure that you have computed correctly the range and the number of classes. So round off C to the nearest value with precision the same as that with the raw data. So meaning of this statement that your C, your class size, will be rounded off to the nearest value with precision the same as that with the raw data. If your raw data is 1 decimal place, so all of your raw data are in 1 decimal place, the value of C must also be 1 decimal place. If the raw data are 2 decimal places, then the value of C must also be rounded off to the number to 2 decimal places. Since in our given, the data are consist of whole numbers, so we will round off the class size to the nearest whole number. So given by the formula C is equal to R divided by K, where R is equal to 73 and K is equal to 8. Therefore, by substitution, C is equal to 73 divided by 8. Since the given raw data again are all in whole numbers, therefore we will round off the C or the class size by the nearest whole number. So 73 divided by 8 is equal to 9.125 or 9.125, which is approximately equal to or rounded off to 9. Then you will write it down here. C is equal to 9. So you already have your R, 73, K is equal to 8, C is equal to 9. So the next step in constructing the sample group, the group quantitative FDT, is by naming already the table. And table 1, as reflected earlier in the previous slides, table 1 is the weight in kilograms of the 60 students of mathematical statistics for IT who participated in answering the student information sheet or SIS. So first, you will compute for R, compute for K, compute for C, then table title. Again, table titles are always above the table, while figure titles are always below the figure or the graphical presentation. So next is the class interval. So how will you know the class interval? Construct the classes or the class interval. So a class interval is defined by a lower limit or LL. Makikita niyo yan sa kanina. Ito, classes. This is the class interval. Class interval classes. So a class interval is defined by a lower limit, LL, and an upper limit, UL. The lower limit of the lowest class is usually the minimum of the data set. The LLs of the succeeding classes are then obtained by adding C to the LL of the preceding classes. So first is the class interval lower limit. We will do first the lower limit. So by the definition of the lower limit class interval, you have to identify what is the minimum value. And in this case, the minimum value is equal to 27. Then, you are just tasked to add the C. So again, if your R, your K, and C are wrong, the entire FDT will be wrong. So your minimum value is 27. Your C, or the class size, is equal to 9. All you have to do is add according to the definition of class interval. add to the preceding classes. So the lower limit, it is given by the formula lower limit is equal to minimum plus C. By substitution, lower limit is equal to 27 plus 9. Therefore, this is the next class because your first class is 27. The next lower limit class is 36. Completing everything, so the lower limit, the lowest is 27. Next is 36 plus 9, 45 plus 9, 54 plus 9, 63 plus 9, 72 plus 9, 81 plus 9, 90 and plus 9 again, 99. So counting, so what is the meaning of class size? That 9 earlier, yung kaninang class size, ito kinompute natin. Saan na yun? Eto, yung class size na yan, etong number of classes, the number of classes, this one should be 8. So therefore, yung number of rows should be 8 or plus minus 1, the margin of error. So let's count if we are correct. So we will count 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we are still correct because the number of classes is 8 and according to the margin of error, it should be plus or minus 1 because the number of classes as stated earlier may or may not equal to the computed number of classes. So here, the lower limit, starting from the minimum, just add the C or the class size to get the preceding values. Question? Before we proceed to the upper limit, in computing the upper limit. Okay, none? Next is compute. Someone raised hand. Meron ba? Okay. Wala. So to compute the upper limit, the UL or the upper limit of the lowest class, pag sinabing lowest class, ito, yung first. Tawag dito, first class, second class, itong 36, third class, 45, fourth class, 54, 63, up to 99, which is your ninth class. So the upper limit of the lowest class, yung unang-una daw, is obtained by subtracting 1 unit of measure, 1 over 10 raised to x, where x is the maximum number of decimal places observed from the raw data from the lower limit of the next class. The upper limits of the succeeding classes are then obtained by adding C to the upper limit of the preceding classes. And the lowest class should contain the minimum while the highest class should contain the maximum. So how will you know if you are correct? If the first class daw will contain, so 27 up to the upper limit will contain the minimum, and since it is reflected here that 27 is the lowest number or the minimum among those data, we are correct because it is under the range of these classes, the first class. And the last class daw or the highest class should contain the highest number, which is 100. And it will definitely include 100. And what is the meaning of this 1 over 10 raised to x or unit of measure? So it only means that the number of decimal places depend again on the number of decimal places on the given. So if you are going to compute it manually, the upper limit, your x is 0 because there are no decimal places among the given. It is stated here where x is the maximum number of decimal places observed. Since among those in the data, there are no decimal places, magkakatalo lang kayo kapag merong data na may 2 decimal places, may 1 decimal place, tapos may 3 decimal places. But since our data, no decimal places involved, so x is equal to 0. And your lower limit, which is the second class, ito yon, lower limit, dito ka titingin sa second class to know the upper limit here. Your lower limit there, lower limit of the second class is equal to 36. By definition, 1 over 10 raised to x, substituting x, 1 over 10 raised to x is equal to 1 over 10 raised to 0. Any number raised to 0 except 0 is equal to 1. So therefore, 1 divided by 1 is equal to 1. So your subtrahend now will be equal to 1. So the upper limit of the first class is equal to the lower limit, which is your second class, minus 1 over 10 raised to x. But our computed value for 1 over 10 raised to x is simply 1. So your upper limit is equal to 36 minus 1. Sa madaling sabi, hindi siya mahirap kung ang data ay pare-parehas. Nagiging mahirap lang siya kapag ang data ay magkakaiba ng decimal places. So I intended that your data are all in whole numbers when you answered your weight, your height, all the quantitative data in the student information sheet so that you will not have a difficulty in solving or computing for the statistical tools in our course. You will only have a difficulty if there is one who answered no answer. If there is one who answered very large, let's say for example, 200 kilograms ang nilagay. But in your case, there is none of those present. So therefore, you will not have a difficulty in answering or creating the frequency distribution table. So therefore, your upper limit, first upper limit is equal to 35. Then you will have to translate it there, right here, 35. To know the succeeding upper limits, all you have to do is again to plus the C or the class size, which is 9. So 35 plus 9 is 44. 44 plus 9 is 53. Plus 9, 62. Plus 9, 71. Plus 9, 80. Plus 9, 89. Plus 9, 98. And plus 9, 107. So imagine if you are wrong already in the computation of R, K, and C, you will already be wrong in computing the LL, the lower limit, and the upper limit. So meaning, from the given data, we will count the next, which is the frequency. We will count the data, how many are falling or included in this range from 27 to 35. What is the frequency? From 36 to 44, what is the frequency? That's why it's group quantitative data because they are grouped. Naka-range 27 to 35, 36 to 44, 45 to 53, up to 99 to 107. So now count the class interval. So yun yung computation niya to know the next. 35 plus 9 is equal to 44. And here are the remaining. Now is the tallying. In layman's term, frequency is just tallying. Just like the manual commonly counting of votes. You will tally the number of frequencies appearing in the data. So tally the data into the classes constructed in the previous step to obtain the frequency of each class. Each observation must fall in one and only one class. You will have an error if you double tallied for a single observation. So just make sure that each observation will only fall in one and only one class. So again, from counting 27 to nakalagay na yun, naisulat ko na. So 27 to 35, the range or this class, the first class is 27 to 35. Counting it here, the number of 27 up to 35, it seems that there is only one, which is this 27. So therefore, you will write the frequency as 1. Next, for the recitation part, count the number of classes from 36 to 44, which is the second class. Only you will count from 36 to 44, given the data. Then tell me, raise your hand, what is the frequency? Taas. Senric,
4 po, sir.
according to the count of Senric, 36 to 44, patay, 7. There are 7. From 36 to 44, there are 7. So 1, 2, 3. Ito pa, 4, 5, 6, 7. 36 to 44, there are only 7. So next count, 45 to 53. How many are included in this class, the third class, 45 to 53? At least, meron pa rin recitation kahit mali. Okay, how many?
18 po, sir.
Wait. 18? 22. Ano ba naman yung bilang na yan? So 45
Sorry.
to 53, di ba nakakadlito? 45 to 53, there are 22. So from this class, the third class, 45 to 53, inclusive yan ha. Pag makita nyo yung 45 tsaka yung 53, counted into this class. There are 22. Next, fourth class from 54 to 62. How many are included in this class? 54 to 62. Yes, Verlin.
10 po.
So there are 10. Uy! Patay, pagbibilang pala. Puro sala na. So from 54 to 62, there are 11. So there are 11 from 54 to 62. So again, in constructing frequency distribution table, if you are wrong in lower limit, the rest will be wrong. If you are wrong in frequency, the rest will be wrong. So just make sure that you count each and every data given. So next, how many? From 63 to 71. from 63 to 71. Ang bilis mo naman mag-count. Oh, Joseph.
6 po, sir.
Okay, from 63 to 71, there are 6. So, double points dahil tama. Double points.
Yun, thank you, sir.
So, 63 to 71, the frequency is 6. Next, 72 to 80. How many are within this limit? Lower limit, upper limit? 72 to 80. So Ken answered 1. There are 2. So there are 2 from 72 to 80. Next, 81 to 89. 81 to 89. Zaki,
8 po.
how many?
8.
8? Hindi ko madinig.
8 po, sir.
Okay, so let's check. Okay, very good. From 81 to 89, double points again. From 81 to 89, there are 8. How about 90 to 98? How many from 90 to 98? Okay, Justin again.
2 po, sir.
So there are 2. Very good. Double points. And the last, 99 to 107. Ferdinand, madali na yan kasi ma-minus mo na lang sa 60. There is only 1. And that is the 100. Yung 100. Wait So there is only 1. So to know if the number of frequencies are correct, all you have to do is to add 1, 7, 22, 11, 6, 2, 8, 2, 1. It should be total to the number of observations. So 8, 30, 41, 47, 49, 57, 59, 60. So we are correct. The number of frequency is 60, number of observations. So next, in the frequency distribution table, after knowing the classes, the lower limit and upper limit, counting the frequency, we will now compute for the relative frequency or the RF. Since it is indicated here, this is in percentage, it's very easy to compute for the relative frequency. So the relative frequency or RF refers to the frequency of the class as a fraction of the total frequency. It is given by the formula RF is equal to the frequency, yung kanina, the previous column, frequency divided by N or the number of observations. RF can be computed for both qualitative and quantitative data. And RF can also be expressed in percent. So all you have to do is to divide the frequency by the number of observations times 100 so that the final resulting value is already in percentage. So RF is equal to frequency divided by N times 100. So I will show you first, the frequency of the first class is 1. The frequency of the first class is 1. And the number of observations we have is 60. By the formula, RF is equal to frequency divided by N times 100. By substitution, 1 divided by 60 times 100, your relative frequency is equal to 2 or simply 2%. So all you have to do is to write the 2. It is understood that this is in percentage because it is already stated in the column header. RF is in percentage. So all of the relative frequencies are in percentages. So no need to write the percent sign. So same, round off to the nearest whole number because we are dealing data, the raw data, we deal it as whole numbers. So next, what is the relative frequency of this one? So let's have some show of hands. So aside from these two, ang dami na nilang recitation agad ngayon. Ellie.
12 po, sir.
Okay, the relative frequency of the next is 12. Very good. Next. Hurricane.
37, sir.
37. Okay, very good. Next. What is the relative frequency of the next class, of the fourth class? Relative frequency. So aside from these two, they have recited already. Others? Ano ka na dyan, Senric? Others? None? Oh, Jana.
18 po.
18. Okay, very good. 18 is the next relative frequency. How about the next? What is the next relative frequency, Arthur?
10 po.
Okay, 10. You are correct. Next relative frequency, Irish.
20 po.
Ha?
20.
20. Tulang ang value. Tulang ang value, oh. Bakit naging 20? So your relative frequency is 3. Because 2 divide 60 times 100 is 3%. Dirk, next.
13 po, sir.
13. Okay, very good. Same value. We have already the 2. So it's 3%. And we already have the 1 value frequency, the first class. That is 2%. To know if your relative frequency is correct, just add the total number. Just add the relative frequencies. It should be approximately equal to 100. There is also a margin of error due to rounding off. So some relative frequencies may have 99% or 101%. So still, the margin of error is plus minus 1 due to rounding off. Especially if the given data will give you decimals. But here, you don't have a problem because the given data, raw data, are all in whole numbers. So next is your CF. So after finding the classes, the lower limit, the upper limit, the F, the frequency, the RF, relative frequency in percentage, we will now find CF, this one, CF, or the cumulative frequency. Cumulative frequency. There are two, less than, by the symbol, less than cumulative frequency and greater than cumulative frequency. So the CF refers to the total number of observations greater than or equal to the lower limit of the class. So that is the greater than cumulative frequency or greater than CF, or the total number of observations less than or equal to the UL of the class or less than CF. So it is very useful in knowing how many of those observations are less than or greater than the given. So from the point of origin, how many are greater than or less than? So let's try in finding the cumulative frequency. It is very easy first to find the cumulative, the less than cumulative frequency. And the less than cumulative frequency always start with the number of frequency here. So all you have to do is to copy ilan ang frequency, isa. To get the next frequency, all you have to do is to add the number of frequencies. So starting with 1, because this is your first frequency of the first class is 1, you will just have to write it down. To know the next cumulative frequency, if less than, you will just add the next frequency. So this one, 1 plus the next frequency, which is 7, that's why it's 8. To know the next less than cumulative frequency, add this one also, 8 plus the next frequency, which is 22. So 22 plus 8, it should be 30. So next, what is the next less than cumulative frequency? Judimar.
41, sir.
Okay, very good. 41. Next, Jericho.
47, sir.
47. Okay, sana matandaan niyo lahat to. Next, Christian Mendoza.
49 po.
49. Okay, next, Anton.
57 po.
Okay, 57. Next, Rona May.
59 po.
Okay, and the last number, Depeche.
60, sir.
Okay, it should be always the number of observations, which is 60. To get the greater than cumulative frequency, it is a tip to start below dito sa baba. Or if you also want, start with the topmost part, then all you have to do is to subtract. But it's easier to add. So I suggest that you start always at the bottom in finding the greater than cumulative frequency. So again, start below the bottom, the most dito. The lowest, you start with 1. Because this is the number of frequency, just copy. The lowest frequency is 1 here. In the frequency, just copy it. Kung 3 yan, you just write here also 3. But since this is 1, the cumulative frequency here is 1. Then, to know the next is to add again. Add the frequency. Or if you want to start at the topmost, you will subtract 60 minus 1. 6. Tapos next, 59 minus 7. But it's easier to add than to subtract. So therefore, copying the frequency of the bottommost, here, the bottommost, which is 1, to get the next frequency, all you have to do is add the next frequency, which is 2. That's why it's 3. To get the next greater than cumulative frequency, add the next frequency, which is 8. So 3 plus 8 is 11. So to get the next frequency, what is the answer? Who else? Uy, lahat sila naka-recite na. Let's roll call again from the start. Arthur.
13 po.
Okay, 13. Next, Dirk.
19 po, sir.
Okay. Next, Zaki.
30 po.
Dami na ni Zaki. What?
30, sir.
Okay, 30. Next, Senric.
42 po, sir.
52. Ano ka ba?
Sorry,
30, plus 22 is 52. Next, Christian.
59 po.
Okay. Mendoza. And the last, Algem.
60 po.
Okay, 60. So I'm stating earlier that you may also start at the topmost, but you will do the subtraction. 60 minus 1 is 59. 59 minus 7 is 52. 52 minus 22 is 30. Same. You will have the same answer even if you start at the topmost. But as a suggestion, you start at the bottommost because it's very easy to add than to subtract. Subtraction, more prone to errors. So you start with the bottom. Just a suggestion, but it's up to you on how you are going to indicate the values of the less than cumulative frequency and the greater than cumulative frequency. So next is finding the relative cumulative frequency. So the relative cumulative frequency is in less than, ito, the first one, and the next is the greater than relative cumulative frequency. So the relative cumulative frequency, or RCF, refers to the fraction of the total number of observations greater than or equal to the lower limit of the class greater than RCF, or the fraction of the total number of observations less than or equal to the upper limit of the class less than RCF. Both the less than RCF and greater than RCF can also be expressed in percentage. In other words, in computation, it is given by the formula RCF is equal to cumulative frequency divided by n times 100. So same as if you are just finding the relative frequency. It just so happened that we are going to compute for the relative cumulative frequency. So just in the less than cumulative frequency, the first item there is 1, and we have the same number of observations, which is equal to 60. And by computation, RCF is equal to 1 divided by 60 times 100, it is equal to 2%. So meaning this all less than CF will be converted into the percentage. So same principle, 1 divided by 1 divided by 60, because that is the number of observations, times 100, that is 2%. So same here, 8 divided by 60 times 100, you will have 13%. 30 divided by 60 times 100, that is 50%. So now, what is the less than relative cumulative frequency of this one, of 41? Arthur.
137 po.
Huh?
Ay,
41 divided by 60, you should not be greater than 100. It's very easy to tell that your answers are correct if your answer is below 100%. So Arthur, 41 divide 60 times 100, rounded off to the nearest whole number.
ano po, 69. Ay, 68.
Okay, 68%. Next. Zaki, again, ang dami nyo na ngayon.
78% po.
Okay, 78. Next, Ellie.
82 po.
Okay, 82. Next. Justin.
95 po.
Okay, next. Irish.
98 po, sir.
Okay, and of course, the last one, 60 divided 60 is 100%. Next, greater than relative cumulative frequency, your point of origin is the greater than cumulative frequency, we start with 100% because 60 divided 60 times 100 is 100%. 59 is the same with this one, so it's 98. Next, 52 divide 60 times 100 is 87. This one is the same with this one, so it should be 50%. Next, relative, greater than relative cumulative frequency. Nag-iipon ka ha. Oh, sige, Irish.
32 po.
32. Naghang. Okay, 32. Next. Zaki again.
22 po.
Okay, 22. Dami na. Next. Justin.
18 po.
Okay, next. Verlin.
5 po.
Okay. And the last, same 2%. So we are about to finish constructing the frequency distribution table. Next is the true class boundaries. It's easy to compute first. The TCB or the true class boundaries. There are two: lower true class boundaries and upper true class boundaries. True class boundaries. So true class boundaries or TCB reflects the continuous property of a continuous data. It is defined by a lower TCB, LTCB, kaya may L sa unahan, and an upper TCB or UTCB. These are obtained by taking the midpoints of the gaps between classes or by using the following formulas. LTCB is equal to lower limit minus 0.5 times 1 unit of measure, and upper true class boundaries is equal to upper limit plus 0.5 times 1 unit of measure. So let's compute first for the lower true class boundaries. So lower true class boundaries or LTCB, as stated in the formula, is equal to the lower limit minus 0.5 times 1 unit of measure. Your lower limit is equal to 27 because that is the minimum value, the lowest of the first class. First class siya. 1 unit of measure as computed earlier is 1 divided by 10 raised to 0. And any number raised to 0 is equal to 1. Because there is no decimal place among the given. That's why it's very easy because there are no decimal places in the given. So 1 over 10 raised to 0 is simply 1. 1 divided by 1 is 1. Multiplied it by 0.5. So 27 minus 0.5 is equal to 26.5. So that is the lower true class boundary, 26.5. It just so happened that the data are all in whole numbers. So if that is the case, all you have to do is to subtract 0.5. So your lowest true class boundaries is equal to 26.5. Same procedure. Your lower limit of the second class is 36 minus 0.5. You will get the next class of the lower true class boundaries. Another way is by adding the class size again. Add 9 to preceding terms to get the lower true class boundaries until the end. So plus 9, 35.5, plus 9, 44.5. Or yung isa, kung gusto mo, tingin ka rito sa lower limit, then you subtract 0.5. 54 minus 0.5 is 53.5. 63 minus 0.5 is 62.5. 72 minus 0.5 is 71.5 until you reach 98.5. Or just by simply get the first one, 26.5, then add the class size. Plus 9, plus 9, plus 9, plus 9, plus 9. Until you reach 98.5. Next is the upper true class boundaries. Same. If the lower true class boundaries is minus 0.5, in upper true class boundaries, you just have to add 0.5. So again, it just so happened that the given data are all in whole numbers, so that one unit of measure will be negligible. So your upper limit is 35 plus 0.5, you will have 35.5. It's easy because the given again are all in whole numbers. So you will have 35.5 because your upper limit here, 35 plus 0.5 is 35.5. To get the next, pwede mo ulit, 44 plus 0.5, 44.5. 53 plus 0.5, 53.5. Or, same principle as finding the upper limits and lower limits, just add 9, which is the class size, to get 44.5, 53.5, 62.5, 71.5, 80.5, 89.5, 98.5, and 107.5. Next, and the final to get will be the class marks or CM. Class mark or CM is the midpoint of a class and is obtained by taking the average of the lower and upper TCBs. That is, class mark is equal to the lower true class boundary plus the upper true class boundary divided by 2, or the average of the true class boundaries. So your lower true class boundary, the first class is 26.5. The upper true class boundary is 35.5. Your class mark is equal to 26.5 plus 35.5 divided by 2, which is 62 divided by 2, or 31. So therefore, your class mark is 31. It is also easier to get the class mark if you are going to add the limits. Add mo lang 27 plus 35 divided by 2, same, 31. 36 plus 44 divided by 2, 40. Or by simply adding the class size, add 9 again to every data, add 9, you will have the following data. Question. We just constructed the frequency distribution table. Yes, Zaki, question.
Sir, ano nga po ulit yung formula ng LL?
Ano?
Ano to yung formula ng LL tsaka yung L?
Nang? Hindi ko marinig. Parang nag-feedback. Yung may parang sa radyo, gumana. Ba't ganun? Ano nangyari? LL and UL. Oh, anong LL? Ito, lower limit and upper limit. So the lower limit can be found by the minimum. What is the minimum value? That is the first class. Then, i-add mo yung computed class size, the C, yung C kanina. So 27 plus 9 to get until 99. Same here, upper limit. How are you going to get? Depending on the second class. We don't have a problem because the unit of measure are all in whole numbers. So therefore, we will just have to subtract this by 1 and we will get 35. Then, to get the upper limits, just add again the class size. Yun ba yung tanong, Zaki?
Ang pagkakarinig ko po, sir, yung formula daw po ata.
Ayun nga, yung sinagot ko.
Po.
Question? Okay. So the specific graphical presentation of the frequency distribution table is the histogram. So that is the name of the graphical presentation of a frequency distribution table. If we are going to graph this into histogram, we will have the following. So these are the frequencies from 0 to the highest frequency, which is 22. So below, this one are the classes. If you can see, 27 to 35, 36 to 44, ito yun, 27 to 35, 36 to 44, up to 99 to 107. So these are the classes below. The frequency, this one, ito naman siya. 1, 7, 22, 11, 6. It just so happened that the interval of the frequency are in 0 to 5, 5 to 10, 10 to 15, 15 to 20, 20 to 25. We just have to reflect 27 to 35, there is only one. 27 to 35, there is only one frequency. 36 to 44, there are 7 frequency. 36 to 44, there are 7 frequency. How about 72 to 80, there are 2. 72 to 80, there are 2. No gaps in histogram of frequency distribution table. Question. So this is how you construct the FDT and the histogram. Uy, tapos na pala yun. Tanong. So if none, I will leave you with this quote to end the first part of our discussion. He uses statistics as a drunken man uses lampposts for support rather than illumination. Naghang. Sinasabi ko, Jiro by Andrew Lang. Thank you and God bless us. So let's have a photo opportunity before we proceed to the next FDT, the ungrouped, because we are done with the grouped FDT. The ungrouped is much easier because I started with the most difficult one, and we will have the final, which is the easiest, when we already have our face-to-face class. Ayan na naman siya. Nagloloko na naman. Jirho, sabi mo nung Wednesday, ayusin mo to. Drawing ka. Drawing ka, sabi mo Wednesday ka pa dyan. Ayan no. Grabe, naghahang. Wait ano ko muna. Yung share screen para makapag-picture tayo before we start the second portion. Ayan, mag-ikot-ikot na naman ang buwisit. Ayan, naku po, ang putragis talaga na ito. Laging sa pangalawa, magkakaganto, pinapanalangin nyo yata eh. Ayan, oh. Oh, hindi ma-close. Naging sa pangalawa eh. Kaya naman na. Ano ba naman yan? Hindi mag-stop presenting. Hindi makapag-picture. Yan. Open your cameras for the start of the second. Uy, busog na si Rona May. China oil. Tell us again, Zaki, if you're about to take the picture. Others, kung unti na naka ano.
Okay, 1, 2, 3.
Another one. Oy, Ramil, kasama kayo pala dyan. Momo na naman yan.
Okay. 1, 2, 3. Okay na po.
Okay, thank you. So let me share my screen again for the second part. Atay! Jerho! Ano na to? Pero nagalaw yung cursor, oh. Nagalaw ang cursor. Ay, nako. Promises are made to be broken. Pinangakuhan ka na nga, gusto mo banto pa rin, no? Ano yung end task? Saan nakikita yun? Shift, Control, Delete. Shift, Control, Escape. Shift, Control, Escape. Ano nangyari? Gagi na lang sa pangalawa. Papagod talaga siya, no? Ang tao nga napapagod eh. Ano nangyari? Naiinis na naman ako. Tapos, right-click, then end task. Shift. Pinindot ko na yung Shift, Control, Escape eh. Diyos ko, time consuming talaga pag ganito. Wala. Nakita ko lang adobo, chicharong bulaklak. Iba pala. Nawala, oh. Nakakainis naman to. Laging sa pangalawa. Wait lang. Nakakainis. Uy, last na to. Anytime. Wala. Ano nangyari? Can't share your screen nakalagay. Diyos me. Grabe, nakakahiya ka. Nakakahiya kang laptop ka. Grabe, nakakahiyang laptop ka. Okay, sige. Thank you, ah. This. Last na eh. So we are done with the frequency distribution table of grouped data. Now is the FDT of ungrouped data. Ano nangyari? Bakit ganito? Teka nga, iihi muna ako. Gulo nito. Nakakabuisip. Sana okay na to. Nakakabulisit na lang. So let's continue. So your seventh activity would be the frequency distribution table for ungrouped data. We have just finished the frequency distribution table for group data. This is easier than the previous frequency distribution table. So ungrouped data, meaning that the number of observations will be less than 30. That's why it falls under the category ungrouped data. So let the test scores of all 20 students be as follows. 23, 26, 11, 18, up to 25, 26, 26. So the following are the test scores. So it's very easy to write the ungrouped quantitative FDT. So again, write the table title. No need to compute for the range, no need to compute for the class size, and no need to compute for the number of classes. Because all you have to do is to write the number of scores appearing. So from lowest to highest. So 9, 11, 13, 18, 20, up to 30. It's also okay if highest to lowest. But for the purpose of our discussion and for uniformity of answers, we will have the test scores or whatever the data given arranged from lowest to highest. So just like in this case, lowest to highest. And the ungrouped quantitative FDT will only involve frequency, relative frequency, less than cumulative frequency, it's less than relative cumulative frequency, the greater than cumulative frequency, and the greater than relative cumulative frequency. So here are the only parts of the ungrouped quantitative FDT, unlike the group, which has the number of classes, the range, the class size, the lower limit, upper limit, class marks, through class boundary. So here, there are only a few of the column headers. So note that the term frequency refers to the number of times an observation occurs or appears in a data set. Hence, in case of repetitions, the frequency increases. So the number of repetitions will tell you the amount of frequency increased, and the table will help you understand this better. So if we are going to count the scores a while ago, so here are the scores. So showing the 9, there is no 10. So next is 11. Just by writing it down single, individually, you will write it down individually, the scores. In repetition, you will just have to count it as frequency. So individually, these are the total frequency. To know if you are correct, just add all the frequencies and it should be total to 20 because there are 20 student scores. So if you're going to count 5, 6, 7, 8, 10, 11, 14, 15, 18, 19, 20. So a total of 20 frequencies and we are correct. Same procedure with relative frequency. 1 divided by 20 because there are 20 students times 100. So in the example, the frequency refers to the number of students getting a particular mark in the test. Also note, wait. Wait lang. Gahang. So to count the relative frequency, percentage, divide again, 1 divide 20 times 100. 4 divide 20 times 100 until you reach the final, the bottommost part of the table. So relative frequency is the relative frequency refers to the frequency as a fraction of a total frequency. So that is RF is equal to frequency divided by N times 100. In the first case, 1 divided by 20 times 100 is equal to 5%. So all you have to do is to write there 5. So to know the next frequency, 4 divided by 20 times 100, you will have 20%. Since we computed for the three next succeeding frequencies, all are 5%. So next, what is the relative frequency of the next? Christian.
10.
Okay, 10%. Same, yung 1 meron na kanina, 5%. How about the 3? Rona May.
15 po.
Okay, 15%. So all the rest, we computed it already. So 5%, 15%, and 5%, 5%. So to know if your answers are correct, just again add the relative frequencies. It should be total to 100%. Same with less than cumulative frequency. Same with less than cumulative frequency. Copy the first frequency that you can be found here in the first class of the table. Just copy it, then 1. To know the remaining, just add the next frequency. So 1 plus 4 is equal to 5. So to know the next cumulative frequency, just add the succeeding number of frequencies. So what will be the next less than cumulative frequency? Lahatin mo na, Senric.
6. 6. 6.
Ano 6 pa rin?
Ay, 6, 7.
Okay.
8.
Okay.
10.
Okay.
11.
Okay.
14.
Okay.
15.
Okay.
18.
Okay.
19, 20.
Okay, very good.
Thank you po, sir.
Thank you. So that is the less than cumulative frequency. To compute for the less than relative cumulative frequency percentage, same principle as if you are computing the relative frequency. Divide by 20 times 100. So 1 divide 20 times 100. 5 divide 20 times 100. 6 divide 20 times 100. 7 divide 20 times 100. So you will have 5, 25. So in multiples of 5 actually, because the number of observations is 20, just so happened that it is in multiples of 5 or a factor of 5. So 30, 35. What would be the next? Until the end. Lorico.
40, sir.
Okay, next. Lorico, lahatin mo na. Busin mo na para mabilis. Nawala. Rona May, lahatin mo na.
45.
55 pa?
Sir, pagkatapos po ng 40, 45.
45 ba?
Diba?
O, lahatin mo na. Zaki.
50 po.
Okay.
55,
Okay.
70,
Okay.
75,
Okay.
90,
Okay.
95,
Okay. And
and
100. Very good. So it's easier again to start the bottommost part to get the greater than cumulative frequency, but it's up to you if you want to start here. You just have to subtract the frequency. But it's easier to add. Start at the bottommost, lahatin na uli, greater than cumulative frequency. Para mabilis. Lahatin na. Ayoko, marami ng presentation. Ang dami nyo, no? Who else? Mga konti pa, pambawi. The others. Oh, aside from this, ang dami na nila. Oh, naka na sila 10 ngayon. Kasi nilahat nila eh. Others? Who wants to try? Greater than cumulative frequency. So add the next frequency. Add the next frequency. Others? Wala? Oh, sige, Cedric, damihan mo ngayon. Plus 20 ka na ngayon.
2,
Okay.
5,
Okay.
6,
Okay.
8.
8.
Ay, 9 pala, sir.
Okay.
10,
Okay.
12,
Okay.
13,
Okay.
14,
Okay.
15,
Okay.
19,
Okay. And finally,
20K.
20. 20K. 20K. O, next, lahat na ulit. Multiple of 5. Minumultiply lang sa 5. Because the divisor is 20. Michael. Plus 10 agad yan.
100,
Okay.
95,
Okay.
75,
Okay.
70,
Okay.
65,
Okay.
80,
Ilan?
60,
Okay.
50,
Okay.
45,
Okay.
30, 25, 10.
Okay. Okay, very good. Plus 10 na na. So we just have constructed the ungrouped quantitative FDT. It's much easier than the quantitative grouped FDT. So for your assessment, I will be uploading this assessment after this discussion. So let the age as of last birthday of the 20 members of the Batong Malaki Senior Citizens Association, BMSCA, who participated in their 2009 Lakbay Aral be as follows. So here are the ages of the senior citizens of Batong Malaki Association. From 61, 64, 74, up to 65 years old. So all you have to do is to create an ungrouped quantitative FDT for the age as of last birthday of the 20 members of the Batong Malaki Senior Citizens Association, BMSCA, who participated in their 2009 Lakbay Aral. So use appropriate title for the table. Do not forget to write the title of that table. And the ages should be arranged from lowest to highest for uniformity of answers, so that I will not be having difficulty in checking your answers. The ages should be arranged from lowest to highest. So here is the sample table. All you have to do is to write the table title. Table 1, period, then the title. What will be the appropriate table title given those data? And the age, frequency, relative frequency, less than cumulative frequency, less than relative cumulative frequency, than relative cumulative frequency. So when you master already the getting of less than cumulative frequency and greater than cumulative frequency, you will not be anymore having difficulty in finding the median, because actually the less than cumulative frequency and the greater than cumulative frequency are used in finding the median, which will be our next topic, the measures of central tendency face-to-face. It's easier to discuss face-to-face. Di ba? Mas madali ang ungrouped quantitative FDT. Question. Before we end. Ang dali, di ba? So if none, I will leave you with this quote. There are 3 types of lies. Lies, damn lies, and statistics. Yes, Henry, you raise your hand.
Napindot lang po, sir.
By Benjamin Disraeli. Thank you and God bless us. Diba? Sinungaling din minsan ng statistics. Yes, sa naman sa kanya, mas sinungaling siya. So let's have the ending photo opportunity. Sana hindi na ito magloko. Kasi pagod na ako nang nagloloko. Pagod na ako sa mga nagloloko. Gaya ni Jiro, sabi Wednesday. Naku. Kaya hindi na ako maniniwala bukas na 1 p.m. Ayusin. Open your cameras for the close opportunity before I dismiss you. Zaki, apakina lang sa sa GC. Salamat. Prompt us when you're about to capture.
Okay, 1, 2, 3. Yeah. Okay na po.
Last one.
Oh, last one. Okay. 1, 2, 3. Okay na po.
Thank you. Ramil, pakisend na lang din yung summary of attendance. Thank you. Bago kayo mag-shot dyan. Ingat kayo palagi. Class is dismissed.
Thank you po, sir.
Bye-bye. Ingat kayo. Diyos ko. Pabagal ng